Now, a dynamic force is the force that happens when something is moving and it hits something that is not moving, and it has to either stop or go through that thing. So in this case, if I was to drop this hammer, and if it was to land on that, there's a force slowing down the hammer. Now that is a lot more than the actual force of 10 pounds of gravity. This can support 100 pounds. So if I was to drop this and it was to crush the can, that means that the actual force is way more than 100 pounds. So what I'm going to do is I'm going to raise it up about 2 feet, I'm going to drop it, and we'll see what happens. As you can see, the can failed.
Similarly, when impact load is applied on the aggregate, it also starts to break into pieces and hence reduce the durability of the structure. And that's why the impact value test become very essential before the use of aggregate as a structural material to use in the concrete. Now, to avoid damage to the structure due to the dead load, impact test is carried out.
Aggregate impact value test. Concrete surface often face sudden impact, that is sudden force. To ensure the compliance of aggregate against this sudden load, aggregate impact value test is performed. Now here we can see the step 1, in which the aggregates are sieved through 12.5 mm sieve and retained on 10 mm sieve, so that we can get the particles of size between 12.5 mm to 10 mm. Once these aggregates are collected, then we can proceed for the step 2, in which the cylindrical mold is filled with these aggregates into 3 layers, each layer being tamped by the tamping rod for 25 times. This is to ensure that there are minimum air voids between the aggregates. Hence, each layer is being tamped with the tamping rod. Now this is the 3rd layer. Again, it's being tamped by the tamping rod, which ensures that the dense package of the aggregate take place and the minimum air voids exist in cylindrical mold. Now once this is done, we weight the aggregate which is taken into the mold. We already know the weight of the mold, so we can get the weight of the aggregate which have filled the mold. Now we can proceed for the step 3. This is the aggregate impact value apparatus which we have placed. Now a hammer of weight of 14 kg is dropped from 38 cm height such that free fall is allowed. Now the aggregate filled with the 12.5 maximum size and 10 mm minimum size is allowed to receive an impact of 14 kg hammer falling from 38 cm height under a free fall condition. Now this is done 15 times. Now due to this impact, the aggregate begin to crush into smaller particles. Now once 15 times impact is over, then the sample aggregate cylindrical mold is taken to find out the amount of aggregate which have been crushed due to the impact. Now we can see the aggregate of size greater than 10 mm and smaller than 12.5 mm have been crushed to a smaller fragment. Now the step 4. We need to again sieve this sample through the 2.36 mm sieve and need to find the amount or the weight of the aggregate which are able to pass through the 2.36 mm sieve. Now here we have taken the sieve which have the spacing size of 2.36 mm and we have placed the aggregates into the sieve. A thorough mixing is done to ensure all the size of aggregate lesser than 2.36 mm falls into the pan so that we can collect the aggregate which are lesser than 2.36 mm. So these are the particles which have sieved through 2.36 mm sieve. Now we will weight these particles. So the aggregate which sieved through the 2.36 mm sieve after the impact value test is weighted. This weight, when divided by the initial weight of the aggregate in the cylindrical mold, give us the aggregate impact value. Now we are weighting the 2.36 mm and smaller size of aggregates. Let's say 61 gram. Now this was the initial weight of the aggregate which we have taken in the sample which have filled the mold. Now aggregate impact value is weight of the fraction passing through the 2.36 mm sieve to the weight of the total material taken. Now this percentage should be lesser than 45. Only then the aggregates are suitable for the use in concrete. So aggregate impact value should be lesser than 45% to be used in concrete and lesser than 30% to be used as the wearing surface. Greater the impact value, more will be the crushing and weaker will be the particles or the aggregates. So this is one of the very initial and very important concept in concrete. An aggregate impact value derives the strength of the concrete.
As per Indian Standard 283, the impact value of aggregate shall not exceed 45% for the RCC structure and 30% for the wearing surfaces such as runways, road and the pavement to ensure the durability of the structure.